So let us begin here. Unit 2, Lesson 3, Absolute Dating. We already have started with it. So the first thing we have to learn is about time, that how is absolute age of the rock can be determined. And then we'll study by, I told you about atoms that day, remember? Atom, neutrons and protons. And then we're going to study about how can absolute age of the rock, what is the best rock for radiometric dating? How do like example, when I'm choosing the rock to know that which year it belongs to, so what is the type of the rock which is best to be selected? And what are the methods to do the radiometric dating by using radioisotopes? What are the methods to know the age? And how can fossils help you to determine the age of the rocks? All of this we are going to study in this lesson. First part we have already finished. That's why just please read it out. Judy or Zishan, any one of you. Determining how can start reading it, please. How can the absolute age of rock can be determined?
Determining the actual age of an event or object in years called absolute dating.
So what is the difference between relative dating and actual dating? When I'm talking about relative dating, I'm not sure. Okay, I was just relating it. I was just comparing it. When I talk about relative dating, this relative means I'm taking A, B, C, D and telling you this is older or this is younger than. I'm comparing it. But here we are not comparing. We are determining the actual age of an event or an object, the rock or the event in the years. This is called as absolute dating. Next year, Judy.
Scientists often use radioactive
Radioisotopes.
isotopes to find the absolute age of rocks and other materials.
Girls, you all know like elements oxygen, nitrogen, fluorine, chlorine, bromine, iodine. You know many, these all are elements. These all are elements. There are special elements in the periodic tables, those like example of uranium. These are radioactive, radioactive isotopes. You don't have to study about them now, but I wanted you to know what are they exactly, to find the absolute age of rocks and other materials. Atoms of the same element that have different number of neutrons are called isotopes. You will not understand this until you know about chemistry, but still I want to tell you, like example, I have oxygen and I have one more oxygen. Both atomic number is 8, but their mass number is different. Their neutrons are different. Again, I have two same element, nitrogen and nitrogen, or hydrogen and hydrogen. Hydrogen is the first element. I write the atomic number. The mass number, they're not same. This is 2 and this is 3. That means neutrons are different. So these are nothing but they are called as isotopes. Like I told you, radioactive element is uranium. Okay, maybe their atomic number or mass number will be 238. This is different. The atomic number will be same, but the mass number will be different. These are isotopes. You will learn more about it later, guys. Because we did not start with the module H is all about chemistry. Maybe in grade 8, you are going to study that, module H. Continue. Zishan, if you are there, please start reading it.
Yes, Miss.
Radioactive isotopes. Please read it.
Radioactive
Radio, you know, radioactive isotopes.
Radioactive isotopes are isotopes that are unstable and break down into other isotopes by a process called radioactive decay. The
Guys, you know that,
radioactive
1 minute, you know that the meaning of decay is breaking down, right? Maybe using chemicals, maybe using anything, decaying. Like I say that decomposers, they decay. So similarly, some isotope, they are unstable and they break down into other isotopes. Some isotopes, they break down into others by process called as radioactive decay. The process is called as radioactive decay. That process helps to break down an isotope into further small isotopes. Okay, continue here, Zishan.
The radioactive isotope is called the parent isotope, and the stable isotope formed by its breakdown is called the daughter isotope.
So this isotope, this element, is the parent one. And after it breaks and form different isotopes, these are daughter isotopes. All right. I told you isotopes means any two element. Either it can be chlorine. Chlorine in the periodic table, the position is 17, girls. It is on the 17th place. So I don't know, it can be the mass number changes. Both are same element, same atomic number, but different mass number, different number of neutrons. This is called as isotope. When these isotope is unstable and they break into further more, maybe 39, 30, 40, 41. So these are called as daughter isotopes and these are called as parent isotopes. This is what they mean today.
Half-life is the time needed for half of a sample of radioactive element to undergo radioactive decay and form daughter isotopes.
Okay, now this parent isotope, it takes some time. It takes time to become what? To become daughter. Parent isotopes, it takes time to become, it takes time here to become daughter isotope. So this half of the time, I'm sorry, half of the time which is taken to decay this parent is called as a daughter isotope. It's called as, sorry, half-life. It's called as half-life. The half of a sample of a radioactive element to undergo, that is called as a half-life. Now, how can the absolute age of rock be determined? After one half-life has passed, one half of the parent isotope has changed into daughter. See, now when you see after half-life has passed, at least one half of the parent isotope have changed into daughter. This one is the parent one. And this is the daughter. So after half of it is changed, it becomes a daughter cell. Now, scientists study the amount of parent and daughter isotopes to date samples. They study the difference between the time from the parent to the daughter. Finding the absolute age of a sample by determining the relative percentage of radioactive parent isotope and stable daughter. This is called as radiometric dating.
Okay.
Now, what is this? This is called as radiometric
Radiometric
What is
dating.
radiometric dating? To determine the age, the difference between, they take the age of the sample by taking the percentage of first parent. They take the age of the parent isotope, and they determine the age of the stable daughter isotope. And this finding the absolute age is called as radiometric dating. Why do you think so? Okay, girls, do anyone know the 3 types of rocks? Igneous rocks, you have sedimentary, One minute, girls. Oh, why it's not erasing? I don't know. Leave it. I'm so sorry, girls. Leave it this one. They have igneous, sedimentary, and then 1 minute. Sedimentary, and metamorphic. They say that best is to take igneous rock. Any one of you can tell me why it is best to take igneous rock? Any idea, girls? What are igneous rocks? Any idea what are igneous rocks? Anyone? I'll explain you.
Okay.
Now tell me what are igneous rocks. Come on, girls. This is called as magma.
Magma.
It comes out as lava. Comes out as lava. It goes and cool and becomes small rocks which are shiny. Igneous rock. So the hot magma that cools and becomes shiny igneous rock. The lava becomes extrusive and the magma becomes intrusive. The hole also here is there. Even these all they cool because of the air entering inside at the top. And these are how igneous rocks are formed. So they're taking the best example of actually granite is a granite, basalt. These all are igneous rocks. What are some radiometric dating methods? Scientists use many different isotopes for radiometric dating. I gave you an example of uranium. In the periodic table, we write it as UR or U, I think. The type of isotope used depends on the type of material we dated. We select this isotope depending upon the material taken. Like which kind of rock you are taking, depending upon that, you choose your element, you choose your radioactive element, or I will call as radioactive isotope. The half of life of the isotope is also very important. It can be too short or too long compared to the age of the sample. You have to be very careful while selecting the age of, while selecting all right. What are some radioactive dating methods? First of all, they say it's called as radiocarbon dating. Radiocarbon dating, where they take the wood, bones, shells, and other organic remains to calculate the age. Everyone they have the constant ratio of radioactive carbon to carbon 12. What is this carbon 14 and carbon 12? Both are same. Both are same elements, carbon and carbon. Okay, but their mass number are different. The number of neutrons are different. That's why they are called as isotopes. Once a plant or animal die, no more carbon is taken in. The ratio between the isotope, because carbon 14 undergoes radioactive decay. When an animal die, you know the ash is left, that is carbon, and after it decay, the 12 change to 14. And this parent carbon changed to many more isotopes, daughter ones. So that's what they're saying. And here it is. I hope you understood. What are some radiometric methods? We studied about radiometric carbon dating. Just before this, we studied about radiocarbon dating. 1 minute, please. Okay, the half-life of carbon is 14. Carbon 14, that is C14, is 5,730 years. Oh my God. The half-life, not even full life. The number of half-life carbon 14 that have passed gives the absolute age. So with this, when I check, the carbon present in that fossil, maybe the eggshell or maybe anything. So when I check in the lab, and if I determine that they contain C14, I know that it lived 5,730 years. Radiocarbon dating can be used to date organic matter only. But of course, I can check only organic matter. I cannot check the pure rock that lived in 45,000 years. Wow. They can check with carbon dating that lived 45 years ago. Okay. What are some radiometric methods? Again, radiometric dating. Now, we finish with carbon. We have potassium, argon dating. We have uranium, lead dating. Okay, I told you potassium. Girls, very weird. You will be astonished, or you will be startled to know that potassium, the symbol is K. Like carbon is C, oxygen is O, and what else? You know, nitrogen is N, sulfur is S, hydrogen is H, chlorine is Cl. But potassium, it is K. Remember, girls. What is potassium? It is K. Girls, this is some extra knowledge, but you must know. You will always write with capital letter. Potassium is K. So we usually, when I have an igneous rock don't have sediments. I mean, don't have fossils. When I usually want to measure igneous rocks that are 100,000 years to billion years old, I go with potassium argon dating. When I want to go with lead isotope in a sample, I go with uranium lead dating. Again, like potassium argon dating was for igneous rock, uranium lead dating is also for igneous rock that are between 100 million to few billion years old. This is 100,000. When it's more old, I go for uranium lead dating. Did you understand, everyone? Tired of alone, talking. So let us watch the video.
Okay.